Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today reciprocal trigonometric functions, reciprocal of trigonometric functions. So under this topic, this consists of the cosecant, secant, and cotangent functions of angle A. So these are the reciprocals of sine, cosine, and tangent functions. We're going to see the problem set in the other screen. So let us check. Okay, this is the problem set. This is for reciprocal trigonometric functions. So this will be about 20 numbers. Yes, 20 numbers. So we're going to solve each one by one per screen. Let's see the first one. Okay, the instruction is here. Find the value of each. Round your answers to the nearest 10,000. Okay, so the first one is cosecant 81 degrees. Now, for the solution of this, this will be consisting of the sine function and the reciprocal of the sine function. And I'm going to show you the formula to do this. So we have cosecant. This is cosecant. Let's have the formula. Okay, cosecant A is equal to 1 over sine A. There. So it's reciprocal. 1 divided by sine A. So for the given 81 degrees, this will be a cosecant of 81 degrees is equal to 1 over sine of 81 degrees. Now you will be using your calculator. So this will be sine of 81. So you only need to determine the sine function of 81 degrees, which is always less than 1 or less than 1. It cannot go over 1, okay? So for sine and cosine. So sine of 81 is 98768 83406 there, and then we shall find the cosecant. All right, and that'll be cosecant of 81. This is now equal to 1.012465126. Okay, so the cosecant function of a given angle will have a magnitude more than 1. Okay, more than 1, because it is the ratio of the hypotenuse to the leg, and the leg is always smaller than the hypotenuse. So cosecant ratio will have more than 1 value. So the answer is cosecant 81 is equal to 1.0125. Okay, rounded to the nearest 10,000. So 4 numbers after the decimal point. This will be 0125. Yeah, okay, and this is our answer. There, okay, and so we have the answer from the computer. All right. There, okay. All right. So that'll be for our first number. Now to give to cite the concept about this reciprocal functions, we can draw a right triangle here. There, and let this be our 90. And let's consider the angle ACB. So this is our angle A. The 90, let that be our angle C, and then the third angle, let that be our angle B. Now sides will be labeled with small letters. So let this be our side B, and this our side A, and this our side small c, there, the hypotenuse. Now the formula for cosecant, secant, and cotangent, okay, will be something like this. Let's define this first. Considering our angle A this is our angle A, if our concern is our angle A, then we have the following. At the left side of the computer screen, we have sine of A, okay, and this will be labeled first, okay. Sine A is A over C, okay, A over C. So this is A over C, okay. This is for sine. Now cosecant is the reciprocal of this. So we have cosecant of A. This will be C over A. It's C over A. It's like that, okay. All right, and this goes to the same as secant, which is reciprocal of cosine. Okay, so we can have cosine of A, which is equal to B over C, and the secant of A is equal to the reciprocal of that, so C over B, okay, C over B, there. Also for the tangent and cotangent, okay, so we can write it here. So tangent of the angle A is equal to opposite over adjacent, that's A over B, and the cotangent, the reciprocal of that, so cotangent A is equal to B over A. There. So these are the 6 trigonometric functions of the angle A. So we will be making use of the reciprocal functions, okay, reciprocal trigonometric functions. So we will be using cosecant, secant, and cotangent. So just remember, considering angle A, if this is our angle A, then this is the opposite side. And this is the adjacent side. And of course, the C, this is the hypotenuse, okay? Hypotenuse, there. So the longest side is the hypotenuse C, okay? So considering these formulas I wrote to the left side of the screen, if you will consider cosecant over here, cosecant is hypotenuse over opposite side, okay? And that's C over A. So hypotenuse divided by opposite side. We're considering angle A. Now the secant, which is right here, that's secant of the angle A, that's hypotenuse divided by adjacent side. So that is C over B. And then the third one, which is the cotangent, is over here. Cotangent of A is adjacent side divided by the opposite side. So that will be B divided by A. And so these three trigonometric functions correspond to the sine, cosine, and tangent, respectively. Okay, so sine is for cosecant, cosine is for secant, and tangent is for cotangent. Okay, so we only need to have the reciprocal of sine to get the cosecant. Okay, it's over here. And we only need to get the reciprocal of cosine to get the secant over there. And then for the cotangent, we only need to get the reciprocal of tangent, which is over here, B over A. There. Okay, that's how to make use of the reciprocal trigonometric functions. And so, if your calculator is only equipped with sine, cosine, tangent, then you have a way to get the other three. Okay, just get the reciprocals. Okay, although modern graphics calculator, scientific calculators have all the 6. Okay, all right, so let's proceed to the next number. Let me clear the screen and then proceed to the second number. All right, here's the second number. Find the value of each. Round your answers to the nearest 10,000. We're doing secant of 70. Okay, here's the formula. Secant of angle A is equal to 1 divided by cosine of angle A. Yeah. So if the angle is 70, let A be equal to 70, then we have secant of 70. This is equal to 1 divided by cosine of 70. Okay, so we'll be able to get this from our calculator. So 1 divided by cosine of 70, and cosine of 70 is, make sure you're set to degrees. Okay, so this is 0.3420201433 there. And so secant of 70 degrees must be equal to 2.9238, 2.92388044. Now, rounded to the nearest 10,000, that will be 4 numbers after the decimal point. So 9238 will be the next 4 numbers. And again, secant is more than 1. Okay, it's always more than 1 because it's the ratio of hypotenuse to the adjacent side. Okay, all right, so it will have to be more than 1 always. So these are the characteristics of secant and cosecant. There, cotangent and tangent may have less or more or exactly 1. Okay, so that's the nature of the ratio of the legs. Okay, so that would be for cotangent and tangent. It can be more than 1 or it can be less than 1. All right, so this goes to our number 2, and let's see our answer. So here's 2.9238 there. So there is the answer. Let's proceed to number 3. Here's number 3. Find cotangent of 3 degrees. Okay, so for 3 degrees, let's have the formula first. Cotangent of A is equal to 1 divided by tangent of A. There. So we have cotangent of 3 degrees. 3 is equal to 1 over tangent of 3 degrees. Okay. So cotangent of 3 is equal to 1 divided by tangent of 3. So let's find tangent of 3 degrees. Tangent of 3 degrees is 0.0524077798 there. And then the answer will be 19.08113669. 3669. Okay. All right. And so the final answer, rounded to the nearest 10,000, this will be equal to 19.0811 only. Okay. 4 numbers after the decimal point. So this is our final answer for the cotangent. All right. So let's check and verify. There. Okay. 19.0811. All right. You can find the answer over there. All right. Next, we'll do the next number, number 4. Here's number 4. Find secant of 21 degrees. We have the formula. Secant A is equal to 1 over cosine of A. This will be secant of 21. This will be equals 1 over cosine of 21. Secant of 21 degrees is equal to 1 divided by, what is cosine of 21? We can get that from the calculator. This will be 0.93358 04265 04265, and then the final answer, secant of 21. It should be more than 1, of course. That's 1.0. That's a 0.711449994. There, 1.071144994. And now rounded to the nearest 10,000, that will be 1.0711. Okay, that's it. There. And so we have the answer 1.0711 over here. There. Okay, 1.0711. Next, number 5. Let's continue with number 5. All right. Here's number 5. Cotangent of 65 degrees. So what is cotangent of 65 degrees? We have the formula. Cotangent A is equal to the reciprocal, of course, 1 over tangent of A. Okay, reciprocals. So we have cotangent of 65 is equal to 1 over tangent of 65. There. And so we continue with cotangent 65. This is equal to 1 over tangent of 65 can be obtained from the calculator. This is tangent of 65. This will be 2.144506921. Yeah. And we have cotangent of 65. This will be equivalent to that's 0.46630.76582. Now rounded to the nearest 10,000, this will be 0.4663. There, and this is it. This will be the final answer. Let's see the answer by the computer. 0.4663. You can check the answer near the question or the given requirement. Okay. Cotangent 65 is 0.4663. You can see it over here. There. That's the answer. So we continue with number 6. Let's continue with number 6. All right. Let's continue with number 6. All right. Find the value of secant of 80. Secant of 80. All right. So start with the formula. Secant A is equal to 1 over cosine of A. Secant of 80 is equal to 1 divided by cosine of 80. There. And so secant of 80 is equal to 1 over cosine of 80. It's cosine of 80. Cosine of 80 is 0.1736481777. And we have secant of 80. All right. We divide 1 divided by the cosine, which is 0.173. So that will be equivalent to 5.758770483. There. Now we have to round our final answer. Is equal to 5.7588. Okay, the 7 becomes 8. Okay, the fourth 7, that will be 7588. There. Okay, that should be it. This must be our final answer. There. And so we have it over here. That's 5.7588. All right, that's correct. There. Okay. Next is number 7. All right, number 7 is over here. We have a triangle, a diagram. So we're going to consider cosecant of theta. Okay, we're going to consider cosecant of angle theta. Now, angle theta is a Greek letter. Okay, Greek letter. So we shall equate this. So let theta be equal to angle A. Okay, so we will. We don't have the Greek letter on our keyboard, so on my keyboard I don't have that. All right, so for simplicity, we can use a Unicode or ASCII code for that, but for an immediate display of that, we shall use the angle A. So I'll just put a letter A over here. There, and then we shall mark the sides according to its names or labels based on angle A or theta. All right, the the 12 or the length 12 is opposite. Okay, so with regards to angle A or theta, this will be our opposite side, and the number 9 is our adjacent side. Okay, there. And of course, the 15, which is opposite the right angle, this should be our hypotenuse there. All right, so I just placed abbreviated words there, which stands for opposite, adjacent, and hypotenuse with respect to the angle theta or angle A. All right, and so we're after cosecant of angle A. And the definition of cosecant will not change. It will be hypotenuse. It will be hypotenuse divided by the opposite side there. So this will be our basis in our there. Okay, hypotenuse over opposite. And so this will now be cosecant of angle A. This is equal to hypotenuse. That should be 15. Okay, 15 divided by 12. Okay, so this will be written 15 divided by 12 there. Okay, 15 divided by 12. Now 15 divided by 12 is not in the lowest term, so we shall reduce this to lowest term. So this will have to be 15 has the factors 3 and 5. So this is 3 times 5 there. And the 12 is 3 times 4 there. And this is actually a fraction like that. And so the 3 will divide by 3. Okay. The 3 cancels out with the 3. 3 divided by 3 is 1. 1 times 5 over 4. Final answer is 5 over 4. So our answer here must be, we have here 5 over 4. So this must be about 5 over 4. There, okay? Then we put the fraction symbol there. All right, so that's it. That should be our final answer, okay? It's reduced to lowest term, okay? That's hypotenuse over opposite side, okay? That'll be for cosecant of theta, okay? And that's it. What's the answer from the computer? All right, the computer displayed right beside the diagram there, it's blinking. That's 5 over 4. All right, that will be it. Okay, that's it. And we're correct, okay? This is our answer, it's correct. Let's continue with number 8. So that's the way to do it. Let's continue with number 8. All right, here's another diagram. All right, and let us see the angle in question. All right, here's the angle again. There, it's a Greek letter theta. We shall put a label A there, just another name A there. And then opposite the angle A is the 9. So this must be marked opposite. And then beside angle A, all right, is the adjacent side. That goes to number 3, okay, the length of 3. Now the radical expression 3 square root of 10, that's the exact value of the hypotenuse. So this is hypotenuse over here. There. So we put the labels properly with regards to angle theta or angle A. All right, we can now have our cosecant. So we're after cosecant of theta. We will replace it with A. We gave it another name A. All right. Cosecant of A will still be the hypotenuse. Okay, the same formula, hypotenuse divided by the opposite side. Okay, there. So that will still be our formula. There. And so this will be cosecant of angle A is equal to hypotenuse, and that is 3 square root of 10. So hypotenuse is 3 and then square root. Let me put a square root there. Let me do it manually. Square root of 10, okay? And this will be over here. There. and put it a little inside, and then this will be divided by opposite side. What is our opposite side? It's 9. Okay, our opposite side is 9. Let me clear that. Let me clear that. This is divided by 9. Okay, so our opposite length is 9. Now, this is not yet reduced to lowest term. The 3 and the 9 can divide. Okay, and we have there 3 and then the square root. This is the square root. And there's a number 10. And then the 9 can be factored. Okay, the 9 can be factored to 3 times 3. There. And so the 3 divides by 3. This number 3 here. This 3 divides by this 3. And final answer is square root of 10 over 3. So our final answer should be cosecant of A is equal to square root of 10. This will now be just square root. We have there square root of 10. And then this is to be divided by 3. So this is divided by 3. There. Okay. Square root of 10 over 3 is the final answer. This is our final answer. There. Okay, so let's check the answer. All right, so that's it. All right, right beside our diagram, you can see the computer's answer over here. Okay, exactly what we did over here. All right, and so that goes to our number 8. Let's continue with our number 9. Number 9 now. All right, we have another diagram with the question, all right, cotangent theta. What is cotangent theta? Or find the value of the trigonometric function cotangent of theta. This is our diagram. This must be the theta. And let's put a label there. Let's use another angle A. So that opposite angle A is over here, the 20. Okay, this is the opposite side. Now, hypotenuse is the longest side. This must be the hypotenuse. And of course, beside angle A is the number 15. That should be the adjacent side. All right. Now, cotangent has the formula. Cotangent of angle A will have to be adjacent side. It's got to be adjacent divided by opposite. Okay. All right. That's the formula. So this is the formula. And so cotangent A is equal to 15 over 20. Okay. 15 over 20. That's adjacent over opposite. So this is cotangent of angle A is equal to adjacent. That's 15. This will now be 15 divided by 20. There. And so this is it. But not yet. That can be reduced to some lowest term. Okay. Remember, there are factors for this. Okay. So let's continue to the other side. And then 15 can be factored to 3 times 5. And then the 20, that will be about 4 times 5. Okay, that's 20. All right, so remember this is a fraction, which we can cancel out something. Okay, we can cancel out the 5s. So we can cancel out the 5 and the 5. We have 3/4. So cotangent of A, we have cotangent of A, that's equivalent to 3/4. So we have here the 3 and 4. There, okay, that should be our answer. There, 3/4. All right, that should be it. And we will check and verify from here. Check and verify. What's the answer near the drawing? Okay, there. Okay, so we have the answer 3/4. And this goes to our number 9. Let's continue with our next number 10. Let me clear the screen. Here's our next. Find the value of the trigonometric function. Number 10, cosecant of theta. Our theta is over here. There, okay? That's our theta. We shall put another name to it. We'll call it angle A, and opposite angle A is the 18. So this must be the opposite. And beside angle A, that's the number 6, okay? The length of that side adjacent is 6. So this is adjacent side. And the other remaining 6 square root of 10, this is the longest side, hypotenuse. There. Okay, we shall apply the formula for cosecant. So we have cosecant of A. All right, the formula for cosecant is hypotenuse divided by the opposite side. Okay. All right, so we will just pick this up from our triangle because we already labeled the sides in the first place. All right, so that will be it. So this will be cosecant of angle A is equal to hypotenuse. That's 6 square root of 10. So this is 6, and then let me draw the square root. Square root of 10 there, and then this is to be divided by, all right, that's the hypotenuse divided by opposite. Opposite happens to be the 18 unit length, so this must be 18. This must be 18 over here. 18 there. All right, so we can continue this over here. This b equals 6. So we have a 6 here, and square root of 10. Let me just rewrite it so I can show you the simplification. This will now be, of course, 10. Now 18 can be factored to 6 times 3, okay? 6 times 3, so that will be at the denominator, 6 times 3 there. And then we complete the fraction. And so you can see the 6 numbers. This divides by the other 6 there. And so the final answer should be, we have the final answer, cosecant of A is equal to square root of 10 over 3. So this must be square root of 10 over 3. So let us put the numbers 10 and the 3 below, all right, over here. And we have the answer, okay? This must be our final answer. All right, let's check and verify. Yes, it's over here. The answer of the computer is over here, beside the drawing there. All right, same as ours, all right? This is our answer. Number 11, let's continue with number 11. Okay, continue with number 11. Here's number 11. We have another drawing. Find the value of the trigonometric function. So you see, we will be only solving cosecant, cotangent, and secant. These are the reciprocal functions, okay? Reciprocals. Okay, so secant of theta, we shall put the label. This is our angle A, and the angle we're talking about is this, there, okay? All right, so we're going to find the secant of this angle. Now we shall define the sides, okay? Opposite to angle A, the 12, and adjacent to the angle A, it's the 9, so this is adjacent. And then the 15, that is the hypotenuse. There. All right, so we shall make use of the formula for secant. The secant of angle A must be equal to the hypotenuse. All right, hypotenuse divided by the adjacent side. This will always be the formula. The ratio of the hypotenuse to the adjacent side, to the angle that we're considering. So for our ratio, the secant of angle A is equivalent to 15 divided by adjacent, which is the 9. Okay, so this is our fraction. Okay, but then this looks like reducible to lowest term. So we shall reduce this to lowest term by getting the factors of the numbers. 15 is equivalent to 3 times 5, and the 9 is equivalent to 3 times 3, and we can cancel out numbers there. Okay, still a fraction, and then we can cancel out the 3. 3 divides by the 3, and it looks like secant of A is 5/3. Our answer is 5/3. Secant of angle A, this is equal to 5/3. So this is now 5/3. Yeah, okay, 5/3. And this will be our answer. All right, so this is it. So this is 5/3. Okay, this is for secant of A. All right, and see, let's see the answer there. Okay, so it's 5/3. You can see it blinking. There is the answer. Okay, 5/3. Now let's do number 12. Let's do number 12. Okay, here's number 12 with a diagram. Find the value of the trigonometric function cotangent of theta. Here is cotangent of theta. Here's the theta. We shall put another name to it. Let's name it with angle A. And opposite that angle is the 24. So this must be the opposite side. And adjacent to that angle is the 7. So this must be the adjacent. And of course, the 25, which is the longest side, must be the hypotenuse. There. All right. So going back to the formula for cotangent, cotangent of the angle should be adjacent divided by the opposite side. So it will be adjacent divided by the opposite side, and we put a division line there. And so our cotangent of A, we shall be able to determine the ratio. Okay, so it's adjacent, which is 7. So we put the 7 over here, and this will be divided by the opposite side, which is the 24. And it looks like we cannot simplify this anymore. There are no number 7 in the 24. So this is it. This will be our final answer, 7/24. And what should be our answer? 7/24 is the answer, okay? All right, so this is it. This is our 7/24. So this must be the right answer there. Next, number 13. Let's continue with number 13. We're doing reciprocal trigonometric functions. Okay, here's the next. In each triangle ABC, angle C is a right angle. Find the value of the trigonometric function indicated. All right, find the value. All right. So we don't have a drawing here, so we shall do the drawing. All right, okay. So we shall have a drawing here. All right, so B and then A, it looks like this. All right, so we will make this our right angle. Okay, this will be our right angle, and we shall provide names to the angles. This must be our angle A, angle C, and then up here will be the capital B, which is another angle. Capital letters are angles, small letters are sides. So opposite angle B is the side small b equal to 3. And then opposite angle A, small letter a, that's the 4. And then the longest side in this right triangle is the hypotenuse C. And that looks like 5 there. Okay, so this is the 3, 4, 5 right triangle. Okay, so this is the popular 3, 4, 5 Egyptian triangle, which is actually exact whole numbers. Okay, and we shall get the cosecant of A. So angle A is over here. There. All right. So cosecant of angle A follows the same formula. Okay. Cosecant of angle A. All right. That should be hypotenuse divided by opposite side. Okay. Cosecant, hypotenuse over opposite side. And this is the ratio of these two sides. Now, this is also equal to what sides in our triangle. Considering angle A, all right, this must be the opposite. And then this must be the adjacent. And the C equal to 5 must be the hypotenuse. Okay, all right, so we have the names of the sides based on angle A. We can now get the numbers from our triangle. All right, our hypotenuse is 5. And this will be divided by opposite side, and that's 4. Okay, so there. And so this is now our required answer, 5/4. This is it. All right. And what's the answer? We can check and verify. There. All right. At the end of the question, you can see the answer. All right. Over here, 5/4. There. Okay. And that is exactly what we have in our answer. Number 14. Let's consider number 14. All right. Here is number 14. Find cotangent of angle A if C is 25, A is 4 squared of 6, B is 23. All right, so again, we shall draw our figure. We shall draw our figure. Let us reduce the number. Let us reduce the size of the letters, so we will have more space. All right, there. Okay, so I'll try to draw it. That should be about, A must be shorter than B, right? Because that's about 2, and yeah, B is longer. Okay, B is longer. So our triangle should look like B is slightly longer like this, and our A is like that, and that's it. This must be the approximate figure, and we will place our right angle, of course. This will be over here. There. And this must be labeled. Our angle C is supposed to be always the 90, and our acute angle A must be over here, and our other angle must be up there. All right. Now the sides. This will be side B, which is 23, and our side C, the hypotenuse, is over here. So this is C is equivalent to 25. And of course, our third side A, this is 4 square root of 6. So we will have to put the square root, and we will draw the square root symbol. And this will be, of course, square root of 6. So there's a 6 inside like that. Now we are ready to determine, okay, cotangent of this angle. Cotangent of this angle. Now we shall put the labels. All right. If our concern is angle A, this must be the opposite side. Angle B is the adjacent side. And side C, of course, the hypotenuse. There. Okay, now we're ready to determine our cotangent angle A. All right, so we shall start over here. Cotangent of angle A is equal to what ratio? It's the adjacent side divided by the opposite side. That's always the formula for cotangent, okay, there. And so this will be equal to, this is equal to, adjacent side from our diagram is 23, okay, adjacent side is 23, and this will be divided by opposite side, which is 4 square root of 6. So we put a square root there. This will be a square root. And we have a division sign there. And this must be 6. There. Okay, but that is not simplified. If you have a square root or any radical at the denominator, the expression is not it's not simplified. So we're going to introduce here rationalization. So we shall multiply this. Okay, we shall multiply this by square root of 6. Square root of 6. So we shall multiply this, all right, by square root of 6 divided by square root of 6. All right, there. And so we put number 6 here and number 6 at the bottom. There. All right, what happens to our expression? This will be cotangent of the angle A becomes 23 square root of 6. So we have here 23, and then there's a square root there. This will have square root of 6. And then this will have to be divided by, all right, going back to the expression in the previous line, that's 4 times square root of 6 times square root of 6. That will become 4 times square root of 36. So this will have a denominator of 4 multiplied by square root of 36. And so you have a 36 inside there, like that. But square root of 36 is exact. That's 6, okay? That's exactly 6. So you will have something like 23. You have here 23 and then square root of 6. So we're going to draw the square root symbol and number 6. And this will have something like 4 times 6 at the next line. So we will have 4 multiplied by 6 there. The square root of 36 is 6. So it becomes like this. Now this is cotangent. Let's put a letter T here. This is cotangent. Yes, it's cotangent A. All right. So this will continue to the next. This will be cotangent of A is equivalent to, all right, let's have our final answer. This will be 23 times the square root of 6, and we have the division symbol. All right, let's put the numbers. In here you have the 6, the radicand, you have the 6 there, and at the denominator you have the 24 there, okay? And there's nothing you can cancel out there. So it must be the final answer there, okay? And so that's it. Let's determine the final answer of the computer. All right, so this will be it. Okay, over there at the end of the line, you can see it blinking. All right, so that's it. And it's exactly what we have down here. All right, so let's continue with the next, number 15. Let me clear the screen. Let's have number 15. Okay, we have the given data again. In each triangle ABC, angle capital C is the right angle. We're asked to get secant of A. The sides are given. All right, so let us try drawing the diagram first. All right, so let's draw it somewhere here. We have the longer side B, and then followed by 6, and then this must be the hypotenuse. Right, let's put the labels. This must be our angle A. This will be our angle C, and this will be our angle B. And of course, this must be our right angle. There. All right. Our sides. Let's put the sides. Side B is 17. Side A is up here, the vertical side. This will be A is equal to 6. And then the hypotenuse, this is C is equivalent to 5 square root of 13. So this is square root of 13. So we put the number 13 inside. That's 1, 3. And we have it over here. This is our diagram. Now, our concern is angle functions of angle A. This is our angle A, secant of this angle. So based on this angle, the following following labels are true. All right. If that's angle A, then this is our opposite side. And this should be our adjacent side down here. And then this is our hypotenuse, okay? Hypotenuse there, okay? All right, and so we can now determine our secant. Determine our secant of A. Okay, so secant of A is equal to the formula. The formula is still true, which is hypotenuse divided by the adjacent side. There. Hypotenuse over adjacent, that will always be the formula for secant, okay? All right, and so this will be hypotenuse over adjacent, and then we can get the corresponding numbers for the hypotenuse and adjacent. And this must be equal to, all right, that's 5 square root of 13. So we'll put the 5 here, and then the square root of 13. So this will have 5 times square root of 13 divided by adjacent side. Okay, adjacent is 17. So we put the number inside the radical, which is 13 first. So this is 13, and the denominator is the 17. There. And so there's nothing we can reduce here, okay? So that means this must be the final answer. This must be the final answer. Let's determine and verify. Okay, that's it. Yes, all right, that's exactly what we obtained. And we're correct, okay? All right, number 16. Let's continue with number 16. All right, here's our number 16. Find cotangent of A if sides B equals 3, A equals 4, C equals 5. All right, we will draw the diagram first. This looks like the 3, 4, 5 again, okay? The 3, 4, 5. So this must be 3, this must be 4, and this must be 5. There, like that. And so this will be our angle A, angle C, and up here is our third angle B. Our 90 degrees over here. All right. And then the sides now. All right. Opposite angle A is side A, which measures 4. All right. And then opposite angle B is the side B, which is equal to 3. And then finally, we have side C, opposite the 90. That's equivalent to 5 there. And that's it. We have the sides and the angles. Now our concern is angle A, cotangent A. So here's our angle A. And based on angle A, this is our opposite side. And based on angle A, our adjacent side is the 3. And of course, there's only one hypotenuse, and that's the 5 there. Okay, knowing these labels, we can now determine our cotangent of angle A. So we have cotangent of angle A is equal to, cotangent is equivalent to the formula adjacent side divided by opposite side. So we have adjacent side divided by opposite side there, okay? And so this is it. You can make use of cotangent of angle A is equal to, adjacent will be equivalent to 3. So our number here is 3 and opposite side is 4. So we divide this by 4. And looks like our final answer is 3/4. That's already reduced to lowest term. And that's it. We can now have this our final answer. We can check and verify what's the answer from the computer. You will see it at the end of the line, okay, in number 16 there, okay. So this is the answer, 3/4, and we're correct. All right, number 17. Let's continue with number 17. Here is our number 17. All right, what do we have here? Find the value of trigonometric function indicated. If secant of theta, find secant of theta if cosecant theta is 5/3. We're after secant of theta. So the Greek letter theta, let angle theta be equal to angle A. Okay, that this will be our sign convention. Okay, we will not use the theta because we don't have that in the keyboard. All right, so we will just replace it with angle A. All right, our given is cosecant of angle equal to 5/3. Okay, 5/3, and so we can try making our triangle based on this. Okay, and so if you have cosecant of angle A, and this is the given, okay, cosecant of angle A is equal to 5/3. 5/3. All right, so we put here the 5, and this will be divided by 3. There, okay, 5/3. Now, our definition of cosecant is hypotenuse. This is equivalent to hypotenuse, right? Divided by the opposite side, okay? That's for a cosecant function, like this. Like this, okay? So in our diagram, if we shall make one, all right? If we shall make one, then our diagram should be like this. All right, we have the 5, okay? This will be our triangle, okay, like this. All right, and our right angle must be this, and our angle A must be over here, and our opposite angle A must be here, and our hypotenuse is the one over here, and that means this is our 5. The length of 5 is this, and the length of 3 is this. Okay, all right, so we don't have the adjacent side. Okay, we don't have the adjacent side, which is right here. There, okay, that's the adjacent side. Now, from Pythagorean theorem, we have the square of the hypotenuse is equal to the sum of the squares of the sides. Okay, namely the opposite and the adjacent side, the legs. Okay, so we have something like this from Pythagorean theorem. From Pythagorean theorem, okay, we have something like hypotenuse, that'll be squared later, okay, hypotenuse, and then adjacent, and then plus opposite. When you square this, okay, so we put a number 2 here, and then put a number 2 there, that will define our formula there, okay. Hypotenuse squared is equal to the sum of the squares of the adjacent and the opposite. Then this must be our 5 squared. This is our 5 squared. This will be our unknown. This is adjacent squared, and then this will be opposite squared. That would be the 3 squared. So we'll put the square now. This will be squared. This will be squared, and this will be squared there. Okay, so it's 5 squared is equal to adjacent side squared is added to 3 squared. This will be 25 is equal to adjacent squared plus 9 there, and we will square the adjacent here. Okay, this will be of course squared there. Okay, now subtracting 9 from both sides, so this will be 25 minus 9 is equal to adjacent squared, and then we have the plus 9 minus 9 like that, and this will still be squared. And so the left side gives us 16. This will be of course 16. Let's put it somewhere above. This will give us 16. 25 minus 9 equals 16. This will now be just adjacent squared. Okay, adjacent squared there. Okay, and the number 9s actually zeros out this and this there. So taking the square root of both sides, we have here something like square root here and the square root here there. All right, and so square root of 16 is 4, and adjacent side is adjacent side there. And so we have the third side. Okay, we have the third side, which is 4. So this means this is 4 over here there. Okay, so that's 4. Now we have that adjacent side, and we're after secant. All right, so secant needs the adjacent side because of the formula. Secant of A is equivalent to hypotenuse divided by the adjacent side there. Okay, so we can make use of the available sides now, and the answer will just be hypotenuse over adjacent. That's 5 over 4. So our answer for secant A is equal to 5 over 4. Let's put the 4 beside 5 there. Okay, so this will now be 5 over 4. This is our fraction, and this is it. That's 5 over 4. All right, that should be our answer there. Okay, you can see it at the end of the question. You see there, 5 over 4. That's the answer over here. All right, number 18 now. Let's continue with number 18. This is our answer for number 17. Continue with number 18. All right, let's continue with number 18. Okay, here's the next. Find cotangent of theta if cosecant of theta is equal to square root of 2. Okay, cosecant of theta is hypotenuse over opposite side. Now, if your hypotenuse is square root of 2, the legs are 1 unit. That's from the special triangle. If you still remember, okay, the special triangle 45, 45. Okay, if you still remember this triangle from the first lesson, okay, this is the square root of 2, and this is the right angle. Okay, this must be the square root of 2, and this measures 1, and this measures 1, and this is 45 degrees. This is 45 degrees, and this is 90 degrees. There. This is the 45, 45, 90 special right triangle. And there, it's the isosceles right triangle. Now, you can see here the hypotenuse. This is our hypotenuse. And this is, of course, all right, which angle should be labeled theta? All right, so we can call this theta is equal to angle A. So we let theta equal to angle A. So we shall assign theta over here. There. Okay. And so we have the longest side hypotenuse. If this is our concern, angle A, then this is our adjacent. And the opposite side is over here. There. Now, the definition of cosecant is hypotenuse over opposite side. So exactly square root of 2 over 1 is square root of 2. Now, we're after cotangent of angle theta or angle A. So we shall determine cotangent of angle A. This must be, of course, adjacent side divided by the opposite side. And we have a very simple solution here. This is 1 over 1, okay, which is just 1. So this is equal to 1 divided by 1, there. And our cotangent of theta is equivalent to 1, okay? So final answer, cotangent theta is 1, there. Special right triangle. And we can check and verify over here. There. All right. You can see below the word find. All right, there. There's the number 1. This is the answer. There. Okay. All right. Let's proceed to the next number. Let me clear the screen. Continue with the next number 19. All right. Number 19. Okay. Here's number 19. All right. Find the cotangent theta if secant theta is equal to 5 over 3. All right. We shall start with the triangle. This is again the 3, 4, 5. Okay. This looks like the 3, 4, 5. And so this is our right triangle. And considering the given, okay, let theta be angle, let the angle theta be equal to angle A. So let this be our angle A. Let this be our angle B. Let this be our angle C. All right, like that. Okay. Now, for secant, the formula is hypotenuse over adjacent. Okay. For secant of A, this is equivalent to hypotenuse. This is hypotenuse divided by adjacent side. Okay. Hypotenuse over adjacent. So this is the formula there. All right. Now, that means our hypotenuse here is the 5, okay, because this must be our secant, and this must be equivalent to 5 over 3. This is the given. And this must be the 5, and that should be the 3. That's the adjacent side, like that. And so we can put this in our diagram. Our 5 over 3, all right, considering angle A. Considering angle A, this is our opposite. And this is our adjacent. Okay, and this must be our hypotenuse. There. Now, putting the numbers for secant A, the number 5 must be over here. And our 3 units must be over here. Okay, let's put it right there. Like that. Okay, all right. Now, this looks like the 3, 4, 5. So the opposite must be measuring 4 units there. Okay, remember the 3, 4, 5 Egyptian triangle. All right, we had a while ago that it's the same triangle. So considering cotangent of angle A, this must be adjacent over opposite side. Okay, we're looking for cotangent. So the question is find cotangent of the angle. And cotangent is adjacent over opposite. So it must be adjacent divided by opposite side there. Okay. All right. So our adjacent, okay, is 3. our opposite is 4. So our answer is 3/4. Okay, so this must be 3/4. So this is equal to 3/4 there. All right, and then we put the division for our final answer. It's a fraction 3/4. Okay, so this is our final answer there. Okay, we shall check and verify. Is it 3/4? Yes. Okay, at the end of the question, you can find it there. Over here, it's 3/4 there. Okay, exactly what we obtained. For our last number, 20, let's consider the next. Here's number 20. All right. Find cosecant of theta if cotangent theta is 4/3. All right, so we will simply draw our triangle. This looks like our popular 3, 4, 5 again. So this looks like 4/3. All right, and this is our right angle there. Again, we let angle theta be equal to our angle A. Okay, so we will put our A here and put our angle C, our 90. All right, so let this be our angle theta. Let this be our angle theta there. Okay, all right. So if we will draw theta, well, it will look like this, the Greek letter. Okay, let me try it there. All right. Okay. Now our given is cotangent theta. Let us determine the labels for the sides. If our angle theta is the same as our angle A, then this is our opposite side, and this is our adjacent side down here. And then the longest side will be our hypotenuse there. Okay. All right. Now the numbers cotangent. All right. For the cotangent is 4/3. Cotangent is adjacent over opposite. Okay. So we have the formula cotangent of A. This must be equivalent to adjacent side divided by the opposite side there. And so we put the division symbol over here. All right, there. Adjacent over opposite. Okay, that's for our cotangent. Okay, adjacent over opposite. Now, cotangent is given, so this must be the 4/3. This must be the 4/3. So this will be 4/3 there. And we put the symbol for the fraction. Okay, all right. So 4/3. That gives us our cotangent. Now remember the 3, 4, 5 triangle. Okay, so we shall place the 4 over here because this is the adjacent side. This must be our 4, and our opposite side 3 must be over here. There. And if these legs are 4 and 3, the hypotenuse must be 5. Okay, there. And we can show that by Pythagorean Theorem again. All right, and so we have these numbers for our sides. We can easily see where cosecant is, okay? And that looks like hypotenuse over opposite side. That's cosecant of angle theta, right? And that should be our answer, okay? Cosecant of theta. Cosecant of angle A is equivalent to 5/3, okay? This must be 5/3 there. There, okay? All right, so this is cosecant of angle theta. All right, the one that is given is 4/3. That's our given cotangent, okay? So our cosecant, which is the unknown, must be 5/3, okay? Let's check and verify. Let us check and verify. There, it's 5/3. You can see the answer at the end of the statement over here. And that's exactly what we obtain over here, okay? That's cosecant of A is 5/3. So this must be correct. And this will be all for now. And I hope you were able to learn reciprocal trigonometric functions. And see you later for other topics. God bless.